Hi everyone, I'm in the chem lab and I'm going to do a flame test today. So a flame test is a qualitative analysis in chemistry to identify the presence of metal ions in a compound. It's a qualitative analysis because we're going to look into the colors of each compound's flame. Okay, so these are the samples that we're going to be using. These are metallic chlorides. A metallic chloride is a compound composed of a metal and chlorine. So we have here copper chloride, we also have calcium chloride, lithium chloride, potassium chloride, and strontium chloride. So as you can see, they're all crystalline solids. Okay, so don't forget your lab gown and lab goggles. So for this experiment, we're going to be using a couple more materials. So here you have some wooden splints submerged in distilled water overnight. These wooden splints are going to be used to pick up your samples. And we're going to need another beaker half filled with tap water for us to be able to dispose of the wooden splints after each trial. Okay, real quick, I want to talk about the Bunsen burner and how you can operate it. So you're going to need a Bunsen burner, rubber tubing, and of course a source of gas. Make sure it's off. And you're also going to need a spark igniter. If you don't have one of those lying around, you can use some matches. Now make sure that your Bunsen burner is also away from objects that can easily burn so that you're going to be safe and secure. Also make sure that the collar over here only partially covers the inlet of the Bunsen burner. Now once you're ready, you can turn on the Bunsen burner. Have this ready with you. Open the valve about 1/4. Get your spark igniter and hover it over the mouth of the Bunsen burner like so. Now you'll notice that the flame is slightly yellow. You want to make it into a blue flame by opening up the inlet by turning the collar clockwise. And as you do that, okay, the flame will slowly turn blue. Well, most of it's going to turn blue. Right? I think this is good enough. So at this point, I put a metal tray behind the Bunsen burner so that we can see the flames a little bit more clearly. So we can go ahead and get our first sample. This is going to be copper chloride. I'm going to open it up. Get a wooden splint. And then get some of that powder onto the wooden splint, not too much. And then go ahead and hover it over where the blue and the yellow flame connect or meet. Now observe the color of the flame. Right. Now we dispose of the wooden splint in the beaker with tap water. We can now move on to our next sample, which is calcium chloride. Okay. Open it up. Get some powder. Again, not too much. And go ahead and do the flame test. Observe the color being emitted. Right, let's dispose of that. And move on to our next sample, which is lithium chloride. Get some powder and then put it over the flame. Observe the color being emitted. Alright. Now dispose of that, and let's move to our next sample, which is potassium chloride. Okay, observe the color of the flame. Alright. Now let's dispose of that and move on to our last sample, which is strontium chloride. Get a wooden splint, get some strontium onto splint and do the flame test. Observe the color being emitted. Okay. And we're done. That's the flame test. Okay, so we're gonna answer two things about the experiment. First, why did the samples emit light? And why were there different colors of light for each sample? Now let's move on over to Bohr's atomic model. Okay, so this is just going to be a general definition. Electrons actually are distributed differently per atom, and there are different numbers of electrons per atom. So I'm just going to try to explain this in the most general way possible. Okay, so before we did the flame test, the atoms in the compound actually were in their ground state. So that means that their electrons were in the lowest energy level possible for the specific element. Now, when the atom was subjected to heat, the electron absorbed the heat, and once it did so, it jumped up to a higher energy level. Now, this is called its excited state. Okay, so where does the color or where does the light come from? Now, when electrons actually don't stay in this state for too long, so what happens is they fall back, okay, to the lower energy level, and as they do so, okay, light is emitted. Specifically, a photon is emitted, and that is actually the light that you see. Okay, so that explains why the samples actually emitted light when they were burned. But why were there different colors of light for each sample? Now, it's important to know this, okay? So electrons can jump to the adjacent energy level, okay? So from first to second. And electrons can also jump to 2 energy levels away or 3 energy levels away, etc., depending on the energy absorbed by the atom. Now, if they jump, they will fall. Okay? So let's say that this electron from the second energy level falls to the first. There is a specific color that is associated with this jump. Okay? Now let's say that the electron jumps from, or falls rather, from the third energy level to the second energy level. That's a different color. Now, what if this electron falls from the third energy level to the first energy level? That is also a different color. And this example is only if you have one electron. What if you have an element like potassium with 19 electrons? Now, for an element like potassium, you can have different electrons jumping to different energy levels. Like, for example, this electron can jump here, or this electron can jump here to the 4th energy level, right? And with that, they can also fall to different places. And recall that for each fall, okay, you would have a certain color associated with it. And imagine all of these electrons jumping and falling to different energy levels. You would have a combination of different colors. And these colors combined make up the color of the flame of the element that you see. In the case of potassium, the color is lilac. Now, since different elements have different ways in which the electrons are distributed around the nucleus, they would react differently to energy that is absorbed. And because of this, we can actually identify the element based on the color of the light that they emit. Take note also that it's only the color of the metals that we see in the compound. The reason is because although chlorine also has electrons that are falling from different energy levels to lower energy levels, the color of light that they produce cannot be seen by the naked eye. And that's it for the flame test. Now, I hope you're able to learn something about why elements emit light when energy is introduced, and I hope you're also able to learn why there are different colors of light for each element. Until the next laboratory experiment, see you and stay safe.